All right, guys, we just finished the errors that could occur. Listen up. Shh, shh, shh. We just finished the errors that could occur if you make a wrong decision. Okay? Well, we were talking about how you compare one proportion to a number, a claimed percentage. Well, guess what? It is actually more common than one proportion hypothesis test to do a two proportion hypothesis test. Because think about it. Frequently, you will compare the proportion of one group to the proportion of another group. Say you, and we will do this towards the end, later this year, we'll do like a food taste test, and we'll compare the proportion of people that like one item to the proportion of people that like the other, a different item. Okay, so compare two proportions. Okay, guys, there's a lot of chit-chat and stuff. Let's settle down. Let's get this done. Shh, shh, shh. So this happens when you perform experiments and you want to see if there's a significant difference in the proportion of successes between the two groups, a treatment versus a non-treatment. Guess what? You will be happy to find that you get to use your calculator to compute all of this information, so that's good. The main difference, other than the calculator doing all of the computing, is that you now have two proportions that you must define. So here we go. Let's do this. The first problem, would being part of a support group that meets regularly help people who are wearing a nicotine patch actually quit smoking? A county health department tries an experiment using several hundred volunteers who are planning to use the patch to quit smoking. So they all use the patch. The subjects were divided into two groups. People in group 1 were given the patch and attended a weekly discussion meeting with counselors and other people trying to quit. People in group 2 also used the patch, but they did not participate in the counseling groups. After 6 months, here's where we get proportion information. In group 1, later, in group 1, 46 of the 143 smokers quit. In group 2, 30 of the 151 smokers quit. Do these results suggest that a support group could be an effective way to help people stop smoking? So we need to define two proportions. So let's do P with the, let's do with a C for counseling. Okay? So what is this proportion? Define it. Proportion of what? Okay, proportion of people, of smokers that wear the patch and go to counseling. Yep. Okay, here we go. You're going to have to write small because you have to define two proportions in here. Proportion of smokers that use patch and counseling. That's not all. That's your denominator. Out of all of the smokers that use patch and counseling, I want to know what proportion of those ones that use patch and counseling that did what? Yeah, that quit smoking. Okay, so be careful that you don't stop right there after the proportion of smokers that use patch and counseling. No, that's not it. It's the proportion of those that use patch and counseling that quit. So the next group is going to be our ones that are the patch only. So I'm going to put a little P there, patch only. Proportion, so this will be the proportion of smokers who use patch only. And then I'm not finished. What goes next after that? That quit. Good. That quit. Okay, good. So the denominator is the proportion of smokers who use patch only, and the numerator is those that quit smoking. Okay. Now, null hypothesis. Our null hypothesis is that the counseling isn't doing anything special. It's going to have the same success rate as the other group. So how would I write that if I want the groups to have same success? So, but I want to use the letters P of C and P of P.
PC equals P of C.
Good. The proportion that quit with the counseling group is the same success rate as the proportion that quit with the patch-only group. So the null hypothesis is their success rate is the same, which in essence, let's kind of think about what is that in parentheses I'm going to put. Let's kind of like put some real world stuff here. What is that saying? What does the null hypothesis say about the counseling?
It is not working. Or it is not.
Yep. Counseling. So this is saying, and you need this because later you're going to be doing the errors. Counseling does not help. So counseling is not significantly improving the quitting rate. Counseling does not help. That's what the null hypothesis is saying. Counseling is not adding benefit to the issue. Okay, so our alternative statement is going to be what? We think the counseling helps. So mathematically I would write that as? Good. The counseling that quit is greater than the proportion that quit that are just in the patch-only group. So in real-world terms, because this is going to help later, that counseling helps people quit. Helps the smokers quit. Okay. Once you've done that, the rest is going to fall pretty easily because we are going to get to just use our calculator. So let's put some information into our calculator. You need to get that if you do not have it. So go grab that really quickly, and I want you to go. So I want you to stat. Here's the calculator steps. Okay, everybody, calculator steps are these. Stat, over to test. And I want you to find 2 proportion z test. That's what we are looking for. So here's what it looks like. Stat, over to test. And then number 6 in my calculator is the 2 proportion z test. Now, I'm going to put in here what you put into the calculator. X1 is the successes for group 1, and in the total sample. And then X2 and N2. So let's put those in here. Okay, write this down so you know what you put in your calculator when it comes to it later. So, group 1. Which ones quit in group 1? Successes. How many successes in group 1? There are 46 out of the 143 who quit smoking in group 1. So that's the numbers we're going to type in. 46 is the successes. 143 is the sample size. So that's what goes into my calculator first. 46. Enter 143. That's group 1. 46, 143. Now, what is the successes in my group 2? 30 and 151. So X2 is 30 successes. 151 is the sample size. So that looks like this. 30 is X2. 151 is N2. Now, what was our alternative? P1 is what? Greater than. So I should be highlighting the last one in that row. P1 is greater than P2. Highlight that last one and go down here and calculate it. You don't need to draw it. Calculate it. Okay, so let me help. All right. Everybody has now computed their test correctly. Listen up. Shh. Hey, focus back. Everybody has computed correctly. Let's now interpret these results. Let's write down our data. This first on your calculator wants you to write down the z-score. I want you to round that to 2 decimal places. How would it be correctly rounded? 2.41, because the 7 makes the 0 go to a 1. And then the p-value is this one that is this plain p, the first p that you come to, which is 0.008. That is your p-value, 0.008. You want 2 significant digits, so technically it's 0.0080, right? Isn't it 0.0080? Okay, questions there? So, painful, it's taking forever. So let's now. So, shh. Guys, please.
Stop talking.
Do you remember when we would compare our p-value to our alpha?
Yes.
What is our default alpha if we are not told one? Okay, so we are going to compare to alpha of 0.05. We're going to put that our p-value of 0.008. And how does that compare to 0.05? It is less than. So we put this in here, and guess what, guys? The p-value is low. So if the p-value is low, reject. So put reject HO. Okay. So since we reject HO, so remember that when we do this, remember what we used to do is we would come up here, and I'm going to kind of put how we're thinking. So we're going to come up here, and we're thinking like this. We are rejecting. You don't have to do that, but kind of like real lightly, you know that you are rejecting the null hypothesis. So that means we do or do not have evidence of HA. We have evidence of HA. Okay, so that's what we're going to write in our conclusion. So there is evidence that P of C is greater than P of P, and that the counseling helps smokers quit smoking. So here's our conclusion, and here's how you write it. There is evidence that P of C is greater than P of P, and this suggests that the counseling helps smokers quit. So you are making 2 statements. First, you're saying that the P of C is greater than the P of P, and then you're putting it in context what that implies or infers. So that then suggests that the counseling helps smokers quit. Okay? Now, guess what the next page is? Yes. So I want you to do this on your own. I'm going to give you a few moments, and then we'll check it. Do it, Wayne. Do them. Okay, so again, your type 1 error, counseling does not work, but we think it does. So we waste money and time on counseling sessions that do not work. Type 2, the counseling works, but we think it doesn't. So I would have probably accepted 2 answers. One, you could say counselors will go out of business because they're not getting jobs, or smokers, this is probably what I'd prefer, smokers do not get the extra help they need because we don't recognize that counseling helps. All right, now we do need to do this second problem because there is a little bit different calculator manipulation involved, so let's do this problem. Here we go. In December of 2002, an issue of Consumer Reports, Consumer Union reported on their investigation of the presence of bacteria in packages of chicken sold in supermarkets. They purchased both name brand Jennie-O and store brand chicken in the United States in 25 U.S. cities. Laboratory tests found Campylobacter contamination, so that's the name of the type of bacteria, in 33% of the 75 Jennie-O packages and 45% of the 75 store brand packages. Does this indicate that shoppers would be safer buying Jennie-O products? Now let's talk for a moment. Are you allowed to say, look, Jennie-O is 33 and store brand is 45, so duh, store brand is worse. Are you allowed to say that? This is one sample, and there is sampling variability. From sample to sample, samples will be different. So you know this one sample shows that the store brand is worse than Jennie-O, but you don't know if it's like way worse, so much that it's significantly worse, that it's not just sampling variability. See? So you have to run a test. You can't just say, duh, it's 45% versus 33%. Is that way worse? We have to see. So let's define these two proportions. P1, what do you want to call these? I'm going to call it P with a little j equals the proportion of, what's our denominator? Proportion of what? Jennie-O chickens is the denominator. Proportion of Jennie-O chickens that what? That have the bacteria that we're looking at. Okay? The next one, P, what little subscript do you want to use for that? How about an S because it's store brand? Proportion of store brand chickens that have bacteria. All right. So our null hypothesis says what about the kinds of the contamination rate? What does our null hypothesis say about the contamination rate between those two brands? Yes, the null hypothesis is that they are always equal. So we start off saying, yeah, Jennie-O contamination is the same as store brand. So does that mean Jennie-O is better? Okay, so I'm going to, remember, I like to put myself a little note here. You know, they're the same rate of bacteria. Is it worth paying more for Jennie-O in that case? So maybe that's what I should have put. Not worth paying more for name brand. That's really, isn't that ultimately what we're trying to figure out? Is it worth to pay more for name brand? Is paying more for name brand going to make it safer? Okay, so what is our alternative hypothesis going to say? Okay, good. Our alternative is saying that paying more for Jennie-O chicken will be safer because you have less contamination than the store brand. So, in essence, what this says is paying more is worth it because of less bacteria. All right. So that, ultimately is the consequences that we're interested in wondering about. So we're going to go into our calculator to do these, but this is where we have little issues with what we put in our calculator and why I specifically want to do this problem. We're going to go into stat over to tests, and it is, again, a 2 proportion z test. So everybody, I need you to do this because there's something different about this than the last problem. 2 proportion z test. So we got x1, n1, x2, n2. And so let's talk about this. What is x1? Okay, so what do you want to put in here for x1? You want to put 0.33? Okay. And then what are you going to put in for N1? 75. Okay, what's X2? 0.45. And then what's the sample size of 2? Okay. What is our tail? We think the first Jenny O is what? Less than. So calculate, and when you calculate, guess what happens? There is an error. And I'm going to tell you why there's an error. This X1 and X2 have to be whole number amount of successes. So you can't just say 0.33. You say 0.33 times 75, and then you have to round it to a whole item. So what I'm going to do is quit, and I'm going to go back in there and try again, because I got an error. So then I go, oh yeah, duh, I forgot. I need to make sure I have whole numbers. So actually just right here in the calculator, I would put 0.33 times 75, enter, and that's 24.75. Am I allowed to have a part of a package? Yes. You cannot have 24.75 packages of chicken. So you must round that to 25. So X1 is 25. What about N1? Whoa. N1 is the total amount. It's still okay to be 75. Now, X2, 0.45 times 75, enter. That's 33.75. Can you open 33.75 packages? No, you cannot. So what are you going to round it to? Round it to 34. Okay, so, all right, I'll be there in just a second. Let me get this in here. Okay, so it should be a less than. We're going to then press calculate. Let me pause and make sure everybody's got that taken care of. You get a negative 1.5 and a 0.066. Negative 1.5 and a 0.066 for your p-value. So let me check you and help you if you have. Okay, so let's talk about comparing our stuff and finishing out this test. Compare your p-value. How does 0.066 compare to an alpha of 0.05? It is greater than, pretty sure it's greater than. So if it is greater than, what is your decision? You fail to reject and write the HO. Fail to reject HO. I take off if you don't put that there. Okay. So if I fail to reject, I want you to think about what this means. I like to come over here. Good. Good. So I failed to reject this. So listen, please. I failed to reject this. So do I know for a fact P of J, the proportion is the same? Do I know that that is true? No, I can't ever say the null hypothesis is true. I just say I have no evidence that P of J is less than P of S. Okay, so that's what I've got going on. So there is, I have no evidence that P of J is less than P of S. So what does that say about it being worth it or not? Is it worth more money to pay? It does not appear that paying more money for name brand makes the chicken safer. It doesn't appear as though paying more money makes the chicken safer. That just happened because of sampling variability. It wasn't significantly better. Could have just happened because of the random sample they got. Okay, so from there, We're almost done. We're just going to do our little practice of these things. So you got the reality, and then what you think, and then you will do the consequence. And so let me let you guys do that on your own, and then we'll check it. Try that now. Okay, let's do our consequences real quick, and then we are done. Okay, type 1 error. Hey, type 1 error. The brand name, Jenny O, has the same contamination, but we think that it is better. We think it has less. So what's the consequence? So it has the same, but we think it is better. People do what? Yeah, good. They waste money buying more expensive chicken when it's not any better. Chicken. When it's not better for you. Okay. Next. How about this type 2 error? The name brand is actually better. So Genio is safer for you, but we think store brand is just as good. What's going to happen there?
People miss out on the opportunity to eat safer chicken.
Okay, good.
And they die.
People miss out on opportunity to buy safer chicken. So, what kind of happens? More people will get what? Good. More people get sick. And then as Lauren puts it, ultimately we say, and die. Okay, so it all results in more deaths, okay? And more people. If you put death on them, then you're going to have it all covered. All right, so there are the ways that we're going to put that into our calculator, and we will do this practice on Monday.